and gentlemen. I'm Carol Champion, Director of Industrial Engagement for the Ontario Centres of Excellence, and I'd like to welcome you to this novel energy storage panel, and it's the key to unlocking renewable power. Before we go any further, I'd like to acknowledge the generous support of Bruce Power, the sponsors of this presentation theatre. Without their help, it wouldn't be possible to stage Discovery as the great event that it is. Enabling electrical energy to be stored so it can be available to meet customer demand whenever needed represents a major breakthrough in electricity distribution and renewable integration. This panel is going to discuss novel ways of storing electrical energy to make tomorrow's grid smarter, greener, and more cost-effective. I would like to introduce you to the moderator for this session, Professor Magdy Salama. Professor Salama holds a research chair in the Department of Electrical and Computer Engineering at the University of Waterloo. So good morning and welcome, Magdy. Thank you.
Thank you very much. Thank you, Carol, for the introduction. I think this is a very interesting topic that we're going to be dealing today with. We have with us 4 panelists. They cover a good range of activities in this area. So what I'm going to do first, I'm going to introduce our panelists to you, and then after that, I'm going to give a brief presentation about the state of the arts of renewable energy storage and the effect of this one on the facilitating renewable energy and smart grid in the system. And after that, I'm going to give 10 minutes, or about 7 minutes, to every presenter to give his presentation about the topic. At the end, we're going to have some questions from the audience and from myself to the panelists, just to bring the subject to the complete exposure, and we'll see where do we stand now with this energy storage, how it's going to impact our system, and what's the value of it in promoting the new grid that we all look for. So I'm going to first introduce our 4 panelists. The first one is Mr. Carver. He's a CEO, Temporal Power. He brings more than 10 years of experience as a technology entrepreneur and management consultant specializing in clean technology. Mr. Carver is the founder of Temporal Power, and he recently led the company in a private financing and government award grant of more than $10 million. Mr. Carver holds a Master of Business Administration from the Richard Ivey School of Business at the University of Western Ontario. Please welcome with me Mr. Carver. Our second panelist is Dr. Rajshekar DasGupta. He's the General Manager of Energy Storage, Electrovaya. Dr. DasGupta is the General Manager, Energy Storage System at the Electrovaya. He leads the company Energy Storage Division, which has developed megawatt-hour scale, distributed scale, and smart capacity, including the distribution planning, power procurement, and marketing. Previously, I'm sorry. Grid energy storage solution. The division has delivered system in each of these categories and expecting significant growth. Dr. DasGupta has also works closely with the research community for the development and introduction of new technology. He has over 7 years experience working with lithium-ion batteries, including fundamental materials and battery system development. He attended Imperial College London, MIT, and Cambridge University. Please welcome Dr. DasGupta with me. Okay, our third Panelist is Dr. Vinay Sharma. He's a CEO in London Hydro. Vinay Sharma is the president and CEO of London Hydro. Prior to becoming president and CEO, Vinay was vice president of customer service and strategic planning with London Hydro. Vinay joined London Hydro on August 24, 1998. His responsibility included customer service, energy conservation management, smart meter initiative, business planning, and retail management. Prior to joining London Hydro, Vinay worked with Saskatchewan Power and Corporation in various capacity, including distribution, planning, power procurement, and marketing. Previously, Vinay was worked as a consultant engineer with Monaco Agra and as an assistant professor in electrical engineering at the University of Saskatchewan. Vinay has a Bachelor of Science in Electrical Engineering and is a professional engineer. He has also obtained an MSc and PhD from the University of Saskatchewan and an MBA from the University of Regina. Please welcome with me Dr. Then we have Mr. Curtis VanWalleghem. He's the CEO of Hydrostor. Mr. VanWalleghem has over 10 years experience helping companies set and exclude on their strategy. Prior to joining Hydrostor in 2010, he has been senior manager in Detroit's corporate strategy consulting practice, where he advised some of the top energy companies in Canada and around the globe. He also held role in cooperative development at renewable energy project developer environmental electric company and business planning at nuclear generator Bruce Power. Please welcome with me Mr. VanWalleghem. So we have our four panelists with us, and I'm going to first start with, as I said before, a brief introduction about the topic, and then after that, I'm going to introduce each panelist with his presentation, and we can continue on that. So the first thing is, the one I'm putting here is energy storage overview, and the main thing I'm showing you here is this is the outline of the introduction. I'm going to talk about mainly the energy storage applications, the energy storage technologies, and the energy storage projects that exist right now. Before we go into the subject, we have to realize that electric energy has to be continuously balanced between generation and demand. So if we turn the light on, that means that we're loading our generator, and once we do that, then basically the balance between the two has to be continuous. The problem is that when we introduce the renewable resources, which have a lot of this variability, which we call the intermittent nature of the renewable resources, a lot of the stochastic nature, wind, solar radiation, and all of these things make the generation, we cannot actually use it for committing a unit or even dispatching it. Because of that, we have a problem of introducing this renewable energy, and the penetration of this renewable resources are limited because of these facts. Energy storage also can support enhance the power system operation, and I put here two main things. I said that high capital cost of managing grid peak demand and to lower large investment in grid infrastructure for reliability and smart grid initiatives. If you look at this two key points that actually are mainly the drives behind this energy storage initiative that we have. What I did here, I tried to summarize some of the application of the energy storage in power systems. Later on, I'm going to show you one slide that shows the effectiveness. I don't want to use the word effectiveness, but what I'm going to use is the costs related to each one of them. And then we'll leave it to the discussion later on to see which one of the storage capabilities or facilities will be suited for which application, which is the main purpose of looking at this subject at large. The first one I said, improving integration of renewable energy, defer for additional transmission and distribution upgrades, arbitrage, buying and selling electricity in different time for profit, improving spinning reserve for power system, enhancing power system reliability, enhancing power system voltage support by fast-acting injection of reactive power, maintaining frequency regulation during irregular grid condition, such as large and rapid changes in the load, act as a buffer that isolate the rest of the power grid from sudden changes in the load, improve power system losses, improve power quality, assist in peak shading, reduce dispatch costs incurred by generating acids, reduce greenhouse emission. You can see the list can goes on and on and on. What I try to see, at least to capture here, are the one that been, or the factors that been studied and evaluated in the literature. Now, this is the second thing is the application of energy storage and power systems. EPRI has done a very extensive study on this. They call it the white paper and the energy storage. And they built a model for actually evaluating the dollar per kilowatt of each one of the impacts that the topics that I mentioned before will do to the system. And you can see over in that line, I'm not quite sure if you can read it clearly, but I'll leave my presentation with all these references. But you can see that some of them are much more effective than the others. Of course, you have to take into consideration the condition and the assumptions that are being made for this calculation. But nevertheless, you can see the different, some of them are up to the 3,000, some of them even they cannot get to 100, so it's a 1 order or 2 order of magnitude difference you can see from the application of each type and how it's impact all of this effect. Now, what I try to do in this slide here is to capture who's going to benefit from the energy storage. Is it the customer? Is it the utility? Is it the generation facilities? And I try to put each one of these things here, like I said, improving the ability and power quality. Customer will benefit, utility will benefit. And then I said utility benefit from T&D asset deferrer. And you can see the general generation facilities benefits from providing auxiliary service, active powers, and integrating more of renewable energy and peak shaving. So you can see that every type of energy storage can target different audience, can target different application. There is a detailed study that's been done again in some of the literatures, but this one is taking every topic and then talking in details. I'm not going to concentrate too much on this one, but there's a lot of analysis, and our panelists are going to touch on each one of this topic in more details. Energy storage technologies, if you look at them, there are battery energy storage system, compressed air energy storage, ultracapacitors, flywheel energy storage, pumped hydro, superconducting magnetic energy storage, hydrogen energy storage. So these are the different type of energy storage that are available. The utilization or deployment of each one of them very much depending on the application, as I said, and how mature is the technology. And of course, if you're going to see in my next slide, pumped hydro is by far the most deployed one. Over here, I also give you a slide that shows the energy storage technology comparison from the peak capital cost per kilowatt, energy capital cost per kilowatt hour, efficiency, maximum power, minimum energy. And you can see the capital cost, how much is going to required to do that. And I think that's already, I exceeded my time. So I'm going to show you one slide, and then after that, I'm going to stop. This is the energy storage project. You can see that over 99% of the storage capacity is pumped hydro, and you can see the different ones over here. There are some in my slides, you can see it later on, some applications that have been done in US and Europe and Canada. We'll come to it in our discussion. So I'm going to conclude here, and I'm going to stop, and then after that, I'm going to introduce our first panelist, Mr. Carver, to come down here and give us his presentation about the energy storage. Okay, thank you.
Thank you very much. Thank you, Magdy. Everyone can hear me okay? Excellent. Okay. So good morning. My name is Cam Carver. I am the CEO at Temporal Power, and we are developers of grid-scale energy storage systems using a flywheel technology. So we're a company that's based out of Mississauga, Ontario. We currently have 8 full-time staff, but are growing and looking for more. So I want to talk to you a little bit about what a flywheel is. So a flywheel is a mechanical battery that stores kinetic energy. So it often spins at greater than 10,000 revolutions per minute. It looks like it's in a cylindrical shape, often made of a carbon composite or steel material. And we're trying to minimize friction as this system spins at high rates of speed. So we often levitate the flywheel using magnets, and the systems operate in a vacuum to try and minimize the friction of the systems. So Temporal Power flywheel technology differentiates itself in a couple of important ways that are all based around the proprietary magnetic bearing system. And the key differences are that our flywheel stores more energy than any flywheel commercially available in the world. We store 50 kilowatt hours. We have an ultra-low loss system, meaning that from full charge, so when it's spinning at its fastest, if you're just to let it spin down, it takes a full 7 days to come to a stop. And this is the first time that we've seen flywheels operate at a price point where it's comparable with advanced battery technologies and makes a lot of sense to be placed on the grid. So these new capabilities are important for a couple of reasons. First off, we store enough energy to be useful in a utility environment. We have a system that's designed for full 20-year life, so in line with other assets that are being used on the grid. And again, it's cost effective today versus alternative solutions to some of the challenges that we face. So energy storage is a key to the modern grid, and we should be excited about the benefits that energy storage can deliver. And so some of the benefits from a high level are that this technology can lower the cost to the ratepayer. Secondly, it can enable more clean energy using existing resources. And thirdly, we can create high-value jobs manufacturing technology that was developed here in Ontario and can be used here in Ontario. I think those are 3 pretty compelling reasons. So Temporal Power focuses on 3 key markets. We call them grid regulation, renewable integration, and remote communities, and I'll talk a little bit about each of those. So grid regulation is the moment-to-moment balancing of supply and demand. At any given moment, there's a difference between those things, and they need to be corrected for. In Ontario, we've relied on the Sir Adam Beck generating station in Niagara Falls to provide this service. You can see the picture of it at the bottom right. Now, the Sir Adam Beck generating station is a valuable power resource to Ontario. It contributes to low-cost, consistent, clean, renewable power in Ontario. We hold back about 100 megawatts of potential generation to provide this grid regulation service. And so we're spilling that over the falls as opposed to using it and generating clean, reliable, renewable power. So we should be doing whatever we can to maximize the use of that clean power, and a flywheel represents a way to do that. So the benefits of energy storage for grid regulation in specific are better use of valuable hydro assets, which I spoke to, lowering the amount of grid regulation required. And so if you look at the graph on the right, what you see here is an analysis done by PJM, which is another grid jurisdiction in the United States, that's implemented rules to say if you use fast-responding energy resources like energy storage, you'll reduce the amount of regulation that you're required. Therefore, the cost to the ratepayer will go down by 5 to 10% because the systems respond faster and there's a lower amount of regulation required. So that graph shows a reduction in regulation and a reduction in cost. We have the benefit as well as improving the stability on the grid, and Temporal Power represents a solution that is the lowest cost per megawatt for Ontario and for other jurisdictions. To sort of drive that point home a little bit further, the graph on the left shows the signal to provide grid regulation in the green that's going up and down, and traditional generating sources that are trying to follow that signal. So you can see they're not quite hitting the mark, they're a little bit slow. On the right, what you have is a Flywheel energy storage system, which is following the signal exactly. And that's why you need less regulation to do this. So it has a number of different benefits, but clearly, I think this slide illustrates the difference and why you require less regulation, therefore spend less money on regulation by using energy storage technology. So the second market that we look at is renewable integration in Ontario. And so here, wind and solar farms are being connected to the distribution network in rural areas. We see that here in Ontario. So wind gusts and cloud cover can cause sudden changes to power output, and that results in power quality concerns on those rural lines. So by using a temporal power solution, we can provide localized power quality support by using stored energy. So inserting energy, essentially acting like a shock absorber, inserting energy when there's a sag, and absorbing energy when there's a spike. And so this solves quite a lot of the issues. We have an exciting project with Hydro One that we're doing for specifically this. The third market is remote communities. And so what this picture here shows in the red are roads, and the green stars are remote communities. So there are many remote communities in Ontario and in Canada and globally that are not connected to the grid. So typically they'll use diesel power generators to supply the base load and all the power needs of that community. So what we offer is a solution where we can optimize the use of those diesel generators by making sure they're operating at optimal efficiency and therefore requiring less diesel to be flown in. We also make the grid more stable in terms of microgrids being able to accommodate wind and solar on weak grid lines. So those are the three primary markets for temporal power. As Magdy pointed out, there's many uses for energy storage, and depending on the technology, you sort of determine where you best fit, and that's where temporal power fits best. So in summary, Ontario can and should be a leader in energy storage for a few reasons. We have the FIT program, which means that we're experiencing new challenges first, and new challenges mean new innovations that have global applications. Ontario has many remote communities on diesel fuel and has a vested interest in reducing that, both from a cost perspective and an environmental perspective. Ontario has inexpensive clean power that can be unlocked. Not every jurisdiction has a Niagara Falls. We have it. We should use it better, so we should be excited about that. And emerging world-leading energy storage technology companies like the ones represented here on the panel are growing and creating jobs, and it's a natural fit for the Ontario manufacturing ecosystem that these are jobs that should be here. And finally, the opportunity is now to capitalize on this competitive advantage with supportive policy that will see energy storage deployed and Ontarians benefit from what these emerging technologies can offer. So thank you very much.
Thank you very much. Okay. Now go with this one. Okay, so our second presenter is Kurt, so please come on down. Okay, thanks. Just going to go with this one here. Excellent. Than mine.
Thank you very much. Hope everyone can hear me okay. Don't know if this is on yet. There we go. So my name is Curtis VanWalleghem. I'm the CEO of Hydrostor. So I'll talk to you a bit about our technology today. If you look for the big yellow balloon, you'll see a bit of a display. I think there's some video there of our technology as well, and a couple of my colleagues are kicking around today to help answer any questions you may have if you want to go in more detail. So a summary of Hydrostor, I think we're a little earlier stage than some of the other companies here. We've yet to receive any kind of big institutional investment. We're still ramping up to get our first grid scale, grid connected facility up and running, and we're targeting to have that next year with a consortium that includes utility host Toronto Hydro and a lot of our primary research being done with the University of Windsor. And I know that I saw Dr. Roop Caravo and Brian Chung here who are really helping us on that. We appreciate it. In terms of our technology, we do compressed air. Compressed air traditionally is done in caves, so giant salt domes underground. They'll fill that with pressurized air. Our solution takes a bit of a different spin on that. We use very inexpensive plastic, and we use the weight of the water as our pressure cavity. It's got a lot of advantages, including being much more scalable than a cave and much more locatable. Yes, we need water, but there's quite a bit of cities and population that live on water, and I'll get a bit more into that. And the way our technology works is we don't use any land on shore. We draw the electricity out through a subsea submerged cable. We run an electrical compressor that basically draws air in, compresses it like an air mattress compressor, a little more industrial, sends the air down a tube into these bladders, and again, you can go see one over there. These bladders inflate just to hydrostatic pressure, so it's the same pressure as the water that surrounds it, and that essentially lifts all the water and now that was above it, and now you have all that gravitational power stored. You can store it as long as you want. The weight of the water then forces that air out, spins a fan, reproduces 70% of what you put in, and very, very low cost. So in terms of our key components, the mechanical piece looks like this. It's one piece of machinery that does the air compression and expansion. This is built on about 15 years of work out of the Texas A&M University. So we've got the global distribution rights in the energy storage space for this. So our innovation's not necessarily around the mechanical portion of it. We focus on how the system fits together and the underwater portion, and that's where our IP and patents sit. The next portion is thermal management. So as you compress air, it gets very hot. If you don't capture that heat, your efficiencies will drop considerably. The traditional compressed air facilities don't capture this heat. That's why they have to burn natural gas to heat it up on expansion so that the air doesn't freeze and damage your machinery. We store that heat, and University of Windsor's been doing a lot of work with us on that to pull the heat out of very fast-moving air, store it in essentially a water thermos, and then reintroduce it to that airstream on expansion. So it's a direct contract exchanger. We keep the heat below 100 degrees so that we can use water, and we don't need to the water doesn't boil and go through a phase change. The accumulators, these are used in underwater marine salvage. And what we've done is we've modified these, taken out certain additional features that weren't needed, and really driving low cost. These things are very inexpensive. They come in 50 cubic meters, so about 8 meters high, 5 meters wide. And again, a bag like that we can probably pick up for about $2,000 to $3,000. Per megawatt hour of storage, you might need 20 or 30 of those. The balance of the plant, we've got platforms. These are used in kind of offshore weather monitoring. Again, we buy these with warranty, that sort of thing, and put it together. Same with the subsea cable and the air hoses. The highlights of this technology, so we've got a very flexible location. So 30 to 40% of all cities are located on water that's suitable for us. So we're not going to be the solution everywhere, but there is a big enough market globally for these. Very scalable, a constant energy discharge profile because the pressure is set by the depth of the water, not how much air you've stored. So that makes the power much more predictable versus a fixed wall cave. 70% round trip efficiency without adding natural gas, I mentioned, very low cost, and every component's proven, been used in other applications for many years. We're just integrating them creatively. So we view our competitive advantage in the storage space as really filling a niche between the large centralized stuff like pumped hydro, as mentioned earlier, makes up the bulk of it. There's limited sites, they can only come in massive scale. So if you don't need that much or you don't have the features for it, you're kind of out of luck. Similar if you don't have that cave for underground compressed air. And then we, again, play on price versus the other competing batteries or storing air in above ground tanks. Our bags are much cheaper than a steel tank is. In terms of our where we are in our development, we've got a pilot system operating in Leslie Street Spit here in Toronto, and we're enhancing that with support from the OCE and University of Windsor this summer. So in the back of the truck is compression technology, thermal management. We then run an airline out to accumulators sitting out about half a kilometer from shore. And so that's been out there since last September. We continue to run cycling tests on that. We're planning a facility with, again, Toronto Hydro. It's SDTC supported. And once we complete our tests this summer, we'll be seeking private funding to round out the budget for that. And we should be up and running 10 months after we close that funding round. What I wanted to focus on, I see I've got about 2 minutes left. This is really the last slide that I wanted to talk to, is what do we see the market for? There's tons of applications for storage. Not every technology can do everything. We're really focused on 3 different streams. One is being an intermediate generator. So we use off-peak electricity as our fuel, and then we can run and provide 4, 6, 8 hours of peaking, predictable, on-demand power, just like a natural gas plant would. So when our competition there really is natural gas plants and coal plants. And so in certain jurisdictions, when they have surplus baseload and prices of off-peak fuel go negative, our fuel is, we get paid to take it versus natural gas. Today, natural gas prices are very low, but in the future, if natural gas prices start to creep up and there's a prevalence of surplus baseload, we are all of a sudden cheaper than natural gas. And so again, that's one market that we're looking for. There's a lot of regulatory barriers that need to be adjusted for that one to really come to fruition, but we've got our eye on it. The next is integration with renewable power. So we're talking to resorts, small towns, marinas in the Caribbean and whatnot that are currently bringing in diesel, very expensive. They put in solar panels or wind. We make that power on demand, and it's cheaper than diesel. So again, we've got a lot of good leads on various communities and projects that want to do that, including the far north in Canada. The next one is standby peaking capacity. So every utility must have X% of their generation in standby capacity. In case something failed, they can trigger it. Right now, they build natural gas plants and let them sit idle and not do anything. We can build our plant and have it sit idle for cheaper than the natural gas plant can. So on a per capex, per megawatt to get it installed, we're 20, 30% cheaper. So we've got our eye on that market as well for standby capacity in the larger cities. And that's really a summary of what I wanted to go through today. On our website, there's a bit more of a video of the technology. And as I said, in the back corner, there's a bit of a display, and I would encourage you to stop by and check it out. So thank you very much.
Yeah, I think the third presenter, Dr. DasGupta, please come now.
Thanks, Professor. So how do I go to yep. All right. So I'm with Electrovaya. We have it's more of a conventional, or in this new market, conventional energy storage method, but of course it's fairly new. We are a lithium-ion battery manufacturer based in Canada, and we are focusing on 2 markets, really. One is the automotive sector, which is electric vehicles, where we're Chrysler's battery supplier, and the second is energy storage, where we're building large-scale and sometimes megawatt-hour scale devices for utility energy storage. So quickly, reasons for energy storage, my colleagues have gone through a few. Basically, it is to enable the grid to be more efficient, allow renewables to be integrated more effectively, and in the end, lower the cost to the customer. So Electrovaya, we are a lithium-ion battery manufacturer based in Mississauga. We are, I think, Canada's only lithium-ion battery manufacturer at the moment, and many patents, et cetera, et cetera. We have a unique manufacturing process which allows us to be very environmentally friendly. So when we were developing our energy storage products for these large-scale energy storage products, basically we leveraged a lot of the development that was done for the electric vehicle market. So we took, for example, this was the Chrysler program, which currently there are about 200 vehicles in testing across the U.S. at the moment. So the one is a plug-in hybrid Dodge Ram, and the other one was a plug-in hybrid Town and Country minivan. So we took this system and essentially scaled it up. So this is a 96-cell lithium-ion battery system in these vehicles, and then we're moving that up to megawatt-hour scale. So in the megawatt-hour scale, this is 10,000 cells plus. So quite a bit of development went into that. The second way we develop these large-scale systems is really designed around safety. When you have energy, even in your hot cup of coffee, that's a fair bit of energy right there. You have to be quite cautious in how you handle that. So when you have a containerized system of 1.5 megawatt hours, we had to think about safety at every level. So there's a very sophisticated battery management system. We're sensing there are about 4,000 temperature sensors in the container. We've got fire suppression systems, and the list goes on. At the same time, we've also been meeting with local fire jurisdictions because these systems are being installed in urban locations. So it's all designed around modularity. It looks like it's composed of data center racks. Each rack contains one of these battery modules. And each one of these battery modules is equivalent to about 3 Toyota Priuses in terms of energy. So in this system we installed in Arizona, it had about almost 500 of these battery modules. So you can see the scale of the system. So this was the system we installed in Arizona late last year. This was a 1.5 megawatt hour battery, and it was paired with a 500 kilowatt inverter system. And the system has been designed so that it could be transported from site to site. So currently it's sitting at a substation, and early next year it'll be moved to a solar farm that they've just finished construction. So as you can see, there's snow on the ground. This is in Flagstaff, Arizona. People kept asking me why I'm taking jackets to Arizona, but it's very cold. It gives also a very large temperature fluctuation, which is good for our testing. So this battery you see there is probably the largest lithium-ion battery ever built in a single container. It was built here in Ontario, so something to be proud of. They are planning to use the system for multiple uses. One is peak shaving in Flagstaff. They have increasing loads, and they want to defer payment infrastructure upgrades in terms of transformers and the like. At the same time, the second aspect of the study is going around the PV, increasing the efficiency of the PV farms that they're building. So we're really looking at those two applications. And we have installed multiple modes of operation in the system and working closely with ABB on this. So this is also a unique lithium-ion battery system in that it's a multi-hour system. So we have to keep control of a battery system from a very high state of charge right to the bottom. So that involves a lot of controls. Most lithium-ion battery systems in energy storage so far have been about 15-minute or half-an-hour systems, and they're using more of the middle state of charge, which is a little easier to handle. So a fair bit of development went into this. Second system we're building is going to be placed in Ontario. It's also a 1.5 megawatt hour system. Quite a few changes on this system. However, it's designed to be completely mobile, so everything is in one container. And it'll be first installed at a solar farm in southwest Ontario, and followed by a demonstration at Ryerson University in downtown Toronto. So this is what that system is going to look like. Essentially very similar to the Arizona system, except everything is packaged in one container such that we can move it around more easily. And as I'm pointing out, it's being located in downtown Toronto. This is one of the benefits of lithium-ion energy storage is that it's very energy dense and can be located in where it's required. So Toronto has a requirement. Peak loads in the summer are very straining the system. At the same time, it's very hard to offer infrastructure upgrades because of there's no space. Same situation is being seen in many large cities around the world. We're also working with another utility in an even larger city, and they even have greater space restraints. So people don't think energy density really matters when you're storing bulk electricity, but it does. So, same time, safety is paramount when you're installing systems next to condos. So, the second, this is another system we're currently developing and will be building later this year. It's one iteration forward on that last system in that it's completely on wheels and it's designed to be dispatchable and immediately installed at a substation level or at a building sites. So this is more of a diesel generator replacement, and the utility that will be taking this system has a large fleet of diesel generators that they use and piss off many neighbors, so they want to go green and have a battery take its place. Anyway, that's a brief overview of the projects we're doing, and I'll be happy to take questions later.
Thank you very much. Okay, Dr. Verma.
Good morning, everybody. It reminds me of school days of mine. Front seats are always empty and everybody sits in the back, but welcome. You just heard various technologies, and Magdy covered a spectrum of technologies, and you saw three that are being researched and developed in Ontario. I'm here to sort of present a different angle on the whole thing, is how do we bring this into the system from a utilities point of view. And Ontario offers a unique challenge because our utility system is so fragmented and rules are so mixed up. The governance is so ad hoc that we have no idea how to begin. But eventually, the idea is to bring this technology and put it into practice. And I've got some thoughts I'll share how we see that it can happen. Of course, first and foremost, technology has to offer us a level of efficiency and economics. If efficiency economics is not there, then we are really going down on a decline, because renewable itself is a low energy intensity system. It has intermittent nature to it. And now we are introducing another technology, which is, by the way, as you saw, is intermittent. It's for a time. And if efficiency is not there, then we are further reducing. Our thermal generating stations already run at very low efficiency, and we're introducing more inefficiency. So efficiency has to be there. Availability has to be there. And of course, economics have to fit in. But more importantly, from our point of view, assuming technology is viable, is how do we integrate this into a system? There are policy issues, but more importantly, there are a lot of engineering issues. Renewable offered us a window to those challenges. I give you an example. In London itself, where we have seen, just like any other urban area, a lot of need or demand from customers for renewable, because it is an attractive contract from the government. So we had, over last 2.5 years, roughly 500 interest from customers, of which majority have been declined because we cannot integrate them into the system. Net result is only 123 are in operation, or connected, I should say, and 10 of them are ours as well. So integration of these technologies is not an easy task. Okay, location matters, size matters, and availability of the system matters. That is the grid. Then is the regulatory environment around it. I know many of you are in the industry, many of you are in the academics. Regulation in Ontario is really a hybrid regulation. There is a part competitive market for the wholesale, then rest of it is all regulated and closed. Basically, there is no risk in the market at this time, as I see it. And finally, that leads me to say that market rules at this time do not recognize, do not encourage any opportunity for system like this. And we have to look at how do we bring those market rules into the existence. And I'll share with you some thoughts that I kind of carry around with me wherever I get a chance to talk about. And they could be somewhere controversial, but we'll see how the audience reacts to it. 10 projects that we have in Ontario, in London, that we have invested $3.5 million in renewable. We see this pattern. I have a slide. I didn't have a slide from my own side because my engineer was not available for me to get that slide. But also his experience is very new because we just finished 10 about November of last year, and this summer we'll see the experience. But here you see the solar generation, it's 8 megawatt panel, and you see how cloud comes in toward the end of the afternoon and destroys that smooth production of power. And then on the right side, this is from ISO website. ISO has a lot of slides like this, gives you an experience as to how energy from wind is produced. So you see the intermittent nature. If sun is shining, solar can produce fairly constant curve. The one that you're looking at the left side is the tracker system. So it tracks the sun, so it's fairly good production throughout the most of the day. But the wind energy, if you look at that for one day only, how each wind generation is, I can't even follow a single curve in there. It's just intermittent, goes up and down, okay, depending on the wind speed. So yes, it makes sense, and it makes very good sense, as we heard from our panelists, that storage will help in a system where you see proliferation of such generating stations. And of course, not to belittle the fact that spilling water in a hydro station is a sin, but we do. So market rules do not allow. And I see the major need in Ontario for storage mostly because of proliferation of renewables. So regulating the production from renewable is a good first solution for Ontario to pursue to integrate storage. There is a negative pricing. It is a perception in the market. We are an integrated market. Yes, we have negative pricing in the fall and spring. It's not a new thing. It happens over many, many years. The reason it has become a heightened concern, and you may not connect the dots, is because of renewable, and I'll tell you why. Negative pricing in the market is not seen by the consumers in Ontario because consumers in Ontario, in addition to the market price, are also paying for a regulated price that is given to contract generation. So the regulated price is so large in the market that it washes away the negative benefit. So you don't see it ever. But when you export, they see it because they do not pay for the regulated generation contracts. So there is a perception, even though market has operated like this forever, but there is a perception now which is heightened. I guess you could certainly say, okay, dump that energy into the Ontario and give a storage outfit that meant negative price, assuming storage is not subject to all the regulated prices. But in order for the storage to work, it has to be a centrally planned system. As I mentioned in my opening comments, hydro is a fragmented industry, so we must have a central planning system. Technology is being developed. As an example, you saw many, and one more is control have been developed. Dr. Verma is here, and Magdy is also working on this. Western Waterloo have developed innovative controls where they can use, for whether it's storage or renewable, a control that can turn that into an inertia-less synchronous generator, so it can provide reactive power as well. From my point of view, I think if we want to bring energy storage into the grid, it must come as a regulated service. Folks, our industry, more or less, from a retailer's point of view, is closed for 20 years because we have 20-year contract, we have awarded, and we are awarding. So it must be regulated services. Utilities should be encouraged. They can invest. It doesn't have to be The reason I say is because private investor will look for 20-year contract. But if you bring into a utility as a regulated service, you basically are guaranteeing through regulation a 20-year recovery of those investments. So it becomes easy to finance those investments. And finally, encouraging development innovation, as OCE has been doing, is marvelous. And I thank OCE for funding so many research projects which are bringing this technology to bear, and also helping development of controllers and various algorithms that are required to integrate the system through the university network. And I really appreciate it. I've become part of it because I felt that this was a very important development for Ontario. So with those folks, I would close and perhaps share with you thoughts as we interact with all panelists. Thank you.
Thank you, Dr. Sharma. Okay, I think now what we're going to do is we can have discussion and questions. We can have it from shaded here from the panelists, or we can open it to the floor. So what I'm going to do is first, I'm going to ask the audience to start the first round of questions, and then after that, I'm going to initiate a second round of questions here. So please raise your hand, come to the microphone, and you can ask the question either to all of us or to a specific person in the panel. Please come on now. Would you please introduce yourself and your name and ask a question?
Hi. Hello. My name is Bob Stasko, and I've been working with OC for a few years, and I think some of the panelists know me. So I'm going to ask a question of the panelists and also the audience at large. Right now, as far as I know, there is no plan for a price for stored energy in a FIT program. And I'm not sure if one's in the works or if any of you gentlemen are aware of it. So I just want to know, what's the status of that situation?
Bob,
Yep.
I'll start off.
Yeah, please.
I'll start off. Right now, it is not in the FIT program because FIT is a very subsidized rate. And it is given for a reason, because investment in renewable generation is slightly expensive. And that was just justification for it. And then based on that justification, it is very difficult to say to somebody or to the consumers at large that go and install storage, which they can arbitrage, as you saw in Magdy's slide, by storing the off-peak power and selling at a subsidized rate throughout the day. So that, I think, destroys the structure of the FIT rate, and that's why FIT contract would not allow. My suggestion is that let's bring some storage at this time, large storage farms. Battery is a very practical system right now. Let's bring as a regulated service, means remove all the regulated charges, let that energy storage system get the benefit of regulated price that OEB, our regulator, can monitor and regulate throughout. And that is the best alternative. There is not much change in policy. It's already out there, and it's an open intervention by intervener system where interest parties can look at the cost and the benefit of that project. Given the fact that IESO, our central operator of the system, do a central planning and say, where will the benefit be it in Southwest Ontario, be it in North Ontario, or be it in the GTA area. So that'll be my suggestion.
Okay, thank you. Go ahead.
Yeah, I was going to say there's some effort. There's an effort going on. Can you hear me okay? There's an effort going on through the Smart Grid Forum, which is a collaboration between LDCs, the IESO, OPA, and others in the utility industry to take a look at a framework for energy storage to determine how you determine values from different stakeholders from energy storage. Now, that's a challenging task, and I know that that's being looked at. I led the group of industry corporate partners who came to the table with recommendations to the Smart Grid Forum to say, look, that is something that needs to be done, but there are some near-term hurdles that can be overcome where energy storage makes sense today, but it's prohibitive on account of rules from participating in the market. Specifically, if an energy storage system is used on the grid and it stores energy and then releases it a couple of minutes later, we get charged not just for the energy, but also all the uplift charges that you see on your bill But then when you put it back on the grid, you don't get compensated for that. So you know, the system when it was set up wasn't designed to deal with energy storage, but we need to be able to make accommodations for this new resource. Secondly, in areas that like grid regulation, energy storage can play today, but the market rules in around procurement make it such that energy storage can't participate in the market. So there are some easy hurdles that need regulatory change but can be made that will allow energy storage to play in the short term. And we see that change having happened in places south of the border and in other jurisdictions. It hasn't happened here yet, but it needs to.
Thank you very much. There's one comment I just want to add to this too is who's going to be the owner of the large facility storage unit? I mean, this is a big question that even I have it here when we talked about. Is the utility going to be the owner of the large storage, or going to be the generation facilities or investors? And how this is going to be integrated in the big picture of the power and generation sales in Ontario?
If I could take that one, and I think it really builds on the comments that were made earlier, is in Ontario, we're looking at the regulations and how you integrate storage, and those decisions are going to determine the answer to that question. If we go the way of California, for example, where they encourage utilities to have a minimum of their generation in storage, then clearly the utilities would then have the incentive to bring it in. If the utilities are told you can include storage assets in your rate base, then the utilities would buy it and it would then be their asset. The alternative is you can say, let's change the rules, put out a FIT, or make certain accommodations so that it's worthwhile for the private sector to build merchant storage facilities. But right now, the rules preclude and eliminate both of those options, and they're looking through how do we make adjustments so that we encourage storage to come to market. And if they make one decision, it'll encourage it to be utility owned, and if they make another, it'll be private sector. And I don't know that our companies really have a vested interest. I mean, we just want to see a path to market open up, whether it be through the utilities or through the private sector investors.
Well, what we're finding is it'd definitely be beneficial for the governments and regulatory bodies to put in new policies such as what we mentioned earlier. But there's so many niche applications out there. For example, we heard from one group who has a piece of equipment that can't shut, has to have 2 hours of uninterrupted power source, otherwise they lose millions of dollars. So they would be interested in a storage device as opposed to diesel generators, which give some problems for them. Same thing with this other utility that's looking at some very unusual application in replacing diesel generators. So I think the number of smaller niche applications out there definitely provide some market as well.
Yeah, this is one of the things I want to just remind the people about it. It's just simply, if you're talking about small generation, like 1 MVA, 2 MVA, that's fine. But if you go to a larger projects, like the one that we have in Sarnia, say 80 megawatt solar system, or the new wind energy now that's coming with 40 and 60, and some of these projects are going to go to the hundreds of megawatts, then the amount of storage that you need to back up your system is going to be huge. And that's going to be a large investment that has to back it up.
See, if I can share some thoughts. There is a small storage already in place. Data centers have storage, they have backup system and whatnot, right? So those niche applications, let market find a solution and let customer and supplier meet at a point where they can serve each other well. But for large storage, as you said, Magdy, I think I am really not for any regulation or legislation that promotes more subsidy for this. Best would be finding where it has the most application benefit to the system and making it a regulated service so that its cost and its revenue are properly scrutinized every year, tested through a process where it's made transparent. so that we don't have this subsidy. It's a fair cost-based system. I think that'll be ours. And in that environment, utilities will be the natural owners of those assets.
Yeah. Any other questions? Yes, please.
It's Steve Sutherland, Calvin Storage. The three firms here are leaders in the storage area, and I know there's pricing breakthroughs happening all the time. I'm just wondering if each of them could tell us what, from a utility perspective, if a utility was going to go out and buy a megawatt hour of storage, what it would cost approximately from each of the suppliers here.
Well, I mean, I'll start by saying it really depends on the application, right? There are applications where you require a few minutes of storage and high power. There are other applications where you don't require as much power, but you need a lot of energy. So it's such a variable question. It's difficult to give you a straight answer on that, but it depends on what you're competing against in a particular application.
Right. Yeah, the scenario might be there's a solar farm, a 1 megawatt solar farm, and you want to have it produce during the evening. So in that scenario, what would the storage component cost the utility, like for a megawatt hour of storage?
So, I mean, our numbers would say in storage you've got effective capacity and then what's actually used, right? If you're not using the storage, it's obviously gets more expensive and whatnot. But I would say that roughly $300 a kilowatt hour is what our forecasts are coming out to be, and that would include the cost of the land, the engineering, construction, everything in kind of turnkey, depending on water depth. But roughly, we're shooting for a $300 kilowatt hour. We haven't built one at that price point yet, so take that for what it's worth.
I'd say it depends on the application to some degree. The power versus energy ratio you're talking about, of course, is critical. Also, the scale of it. If you're talking, 10 megawatt hours, that's a large system, and scale will lower the cost. At the same time as what we're seeing, because we're starting to build these, the cost is coming down substantially by project 3, by project 4, so on and so forth, especially as the commonality gets closer with our automotive programs. So it's hard to give an exact number right now, though.
Thanks. Thank you. Okay, I'd like to thank everyone for your presentation, your discussion. I'd like to thank the audience also for coming to this panel. And then I'll hand it to you. Thank you very much.
Hello. So thank you, Magdy. My name is John Fielding, and I'm the Regional Director for Eastern and Northern Ontario for Ontario Centres of Excellence. Carol, unfortunately, had to go to another session, so I'm helping close this session out. So first, I'd like to thank the panelists. I want to thank them for sharing their insights and their knowledge, both on the emerging technologies and their products, and as well their applications. And I thought it was quite thought-provoking, especially when we got a reality check from an actual provider and some of the questions that came out at the end. I thought that was quite good. And thanks, Magdy, for sharing your research and as well kind of keeping things tied together here. So I'd just like to give you a small token of our appreciation here for the event. Thank you very much. Thank you. I've got one more here.
Thank you very much.
Thank you.
Okay.
Okay, so I want to thank the audience for the participation and as well Bruce Power for sponsoring this booth. And if you want to hang around, in about 10 minutes, there's going to be another riveting panel here, which is a Canadian view of the global marketplace. And that's where they're going to consider how Canadian organizations can help grow promising companies by giving them access to global markets. So please hang around for that. And once again, thank you and enjoy the rest of Discovery.